What's up, everybody? Welcome back. Today we are working on optimizing our path planning algorithm, which is a star, and we're just trying to see how fast can we make it go. So context is we are working on this path planner for Vancouver, BC, Canada. So this is where I live. Well, not exactly here. Somewhere in this region is where I live, and I don't like it when I ask Google how to get to a bar and it tells me to take three fucking slow ass buses that come every 30 minutes and miss a transfer. Like, pisses me off, man. So, let's just make our own path planning algorithm that doesn't piss me off. You know, that's kind of the plan. And so where we're at right now is we have this rendering of OpenStreetMaps data, no bus information yet, no transit, just streets. And we have, as of yesterday, the ability to draw a line from one point in the world to another point in the world. It's really hard to see because the resolution is so low. I don't even know if it shows up after compression. But if we turn on debug path planning, you can at least see some semblance of something. This is showing every node that we looked at on the way. And what happens here is if I go kind of like into some area where there's like a disconnected node, my frame rate, you can see it kind of like dropping down to like 3 frames per second or something. It's like really bad. And so the real problem here is that we are doing the path planning in the render thread. That's fucking stupid. But while we are frustrated by this slowdown, we might as well take some looks and see how much faster can we make this thing? Can we make it so that it's reliably able to plan a full path from anywhere in this area within 1 frame? That's just something I want to see, right? In reality, the real fix here is to make it so that JavaScript kind of pulls some sort of calculator at like some interval so that like it can like do other pieces of work while the calculation is happening. But once we get there, we won't want to fix stuff anymore. So we might as well use the frustration to our advantage at this point. So plan of action is approximately let's benchmark the uber degenerate case. So the worst case here is like there are nodes on this graph that just are not connected to other nodes. And so if we try to plan a path from one node to a disconnected one, then we are guaranteed basically to walk every node in the graph, which is stupid. We should fix that. But if we benchmark that, then that's like a kind of good indicator of like how like the worst case performance of the algorithm. We can use that to kind of like look at, okay, so I know that right now one of the things I want to look at is at the end of last stream we kind of discovered that there are streets rendered in here, but there's also a lot of like hidden data that is like every single building in the city is like in this data, and we stripped it out, we thought, but we actually left some of the like underlying data there. And so all of our node lookup is like using memory for a bunch of nodes that don't exist. So I kind of want to see, once we have like a number of how slow we are, I want to see like how much faster do we go if we just remove all of the nodes that shouldn't be in there, because that would make all cache locality a little better. I would like to also look at the cost of maybe if like all of our our world is stored in float 32 data right now. I would like to see what type of improvements we get if we just kind of like change that to U32s out of curiosity. And then we'll do like actual like benchmark based performance improvements. So I suspect that the queuing that we're using right now, so the A star algorithm is like essentially like take the thing that we think is most likely to be the closest thing, look at that, and then look at the things next to it and try those. And I suspect that like operation of like which thing is closest is we're probably doing something fucking stupid there. So we'll probably take a look at that, but we'll see where the benchmarks take us. But the first thing to do is just get a number for the degenerate case. So we can kind of maybe go into our code, and we can probably go in here and just kind of log the degenerate case. So I think it's in our path planner. I think that when we run, I think we return an error when we don't find a path. Error, no path. So we can just, when we call this guy, log kind of like the node positions, which nodes we are looking at in that case, and then we can figure it out from there. So here we should just be able to say, here, we go from node A to node B. And this is from whatever the fuck we punched into there. So it's path start and node ID. These are the nodes. And let's just recompile. Fuck. Because these guys need to write value because they're strong types. Because I keep fucking up my indexes. It's so hard. It's so hard to keep your put your indexes into the right spot. So we do a little bit of strong typing to avoid that. But it also means that they're not numbers anymore. And I think we should just be kind of like start a plan, a path here, and here. Certainly, we just hit the degenerate case somewhere. But we're logging a bunch of garbage that is not really what I want. So can we get rid of these logs so it's easier to find the logs that I do want? That would be wonderful. Oh, here. Well, okay. I should have done that, but instead, we will not do that. And what I want to do now is I want to kind of like simulate this same thing outside of WebAssembly land because WebAssembly land is slow as shit. Or not slow. I shouldn't say slow. It's the wrong word. It's like, I find it's slow for me to work in. And that might be a familiarity thing. It might be a tooling thing. But whatever it is, I don't care. I just don't want to work in it right now. So I think we need to make sure when we want like app path planner here. He's probably not public. So here we pub this guy. We have to pub his init function probably. And we pub his dinit function, and his run function is already public. So now we can do like init this with thing with our allocator app. What does the thing look for? It's the point lookup and the adjacency map. So points and app.adjacency map. Okay, I think both of these were pointers, if I read that correctly. This probably has to be tried, and you can call this path planner. And then we run the path planner given these two numbers. And these are strong type numbers, so we have to do type of dot value. We do the inverse of what we did when we logged him. And now, he said nothing's, he says not mark pub, but I marked a pub. I just have to save before I mark it. Cool. And then here, this needs to be a variable. We need to try this. Or I guess maybe we expect this to fail. So we'll say catch error. And here we should see no path. That's, if we did everything right, we should see no path here, which would be great for us, because that's the fuck up case. And zig build. Fuck. Nothing ever works. It never is right. Incompatible types. Constant ID and void. Oh, I think I have to discard the value here, because it's trying to give me a path back, but I don't actually want the path. I just want to see how slow making the path is, which is chill. And now, surely we go into map zig out bin map, and we have to pass in the data that we're working with. So it's output map data bin and output map data JSON. And that sure is taking a fucking long time. I don't know what is happening here, actually. That's unbelievably long. What the fuck is going on? Oh, there's also some leakies in here, which isn't good. We should fix those. Well, I guess it's just because we're not running DNet on this thing. But holy hell, that was slow. Like, really slow. Like, way slower than I thought it would be. I wonder if it's just because of, maybe we have to build. Like, is it a debug thing? Is it possible? Is it possible that it's entirely debug? It could be that maybe we're supposed to be buffered. We're not buffered reading the files off the disk as well. That could be related. It'd be kind of interesting to see where the time is going. Segfault. Is it possible that I am using the wrong values here? It seems possible. If like somehow these got desynced from each other. So these are coming from output map data bin at 2940 megabytes. This is output 29.4 megabytes, so it should be. This is quite surprising to me. This is not what I thought was going to happen. But I guess it's good. So he's segfaulting on start value. Yeah, so he's just confused like off rip about like the size of the thing. Thank you. DInit should be deferred. You are right, and that is probably the problem. We're like, hey, we have no memory. Could you write into that memory, please? And he's like, okay, but we might segfault. Makes a lot of sense. Makes a lot of sense. Good eye. Good eye. There we go. Now we get error no path. That's much more what I was expecting. And let's kind of, I wonder like what's taking so long before, but we'll see. So here we'll say debug print starting path planner. And here we will say path planning took this amount of time. And so to do that, we're gonna have to say stood time instant now. This is the start, and this is the end. Yep. And then we have end since start is in nanoseconds, so we can just divide this by like probably milliseconds is fine. Probably. It feels like it's really slow, like really slow, so I don't think we need to get to like microsecond level accuracy. Surely not. Surely we're gonna be in like the hundreds of milliseconds. 344 milliseconds. We should write how long here, and we should new line. Okay, and then maybe we want to get some sort of like consistency out of this thing, so maybe we run it 10 times, just to give you for a little bit of safety, for a little bit of confidence. So here we can maybe say 0 to 10. We'll say num iters is 10. That way we can divide by him later. And we will discard this, and we will run this in a loop, and then we will say time milliseconds over num iters. This took this long on average. All right. Give him a sec, he's thinking. 34? Why did it change? Wasn't it 350 a second ago? What the fuck? Oh. We're keeping the state, and that's not fair. Not fair at all. Because all of the scores will already be populated, and they need to be calculated from scratch for this to be a fair comparison. There we go. That's much more reasonable. Well, not more reasonable, but more expected. I wonder why it's rebuilding every time. I feel like there's something wrong with my cache, so just blaze it. Let's just run it again just in case, because I just feel like there's something wrong there. Because yeah, it should know not to rebuild anything. When I say I just build again, it should go, okay, I already did it, man. It's fine. Don't worry about it. But he wasn't, so. 288, 287. There we go. That's better. All right, there's like some sort of relative consistency there. Now, obviously, I've got like stuff happening on my computer, but whatever. It's fine. It's fine. 288 milliseconds. 288 milliseconds. Write that number down. 288 milliseconds. And I want to know now. I just want to know. I think that like we could do real profiling, right? But I do just want to know if we if we discard all nodes that aren't attached to a way, what happens? Because I think that there's like way too much data, and like the way that this stuff is stored in our path planner, we have these like, we basically say like, hey, for every point that we have data for, allocate some spots for this, right? And so like there's going to be all sorts of data in here that's never used, and it should be like spacing out the other scores. So I just want to know if we get rid of all that stuff, if we see like a reasonable increase in speed. Because it's just I'm curious. That's all. That is all. There's a chance that this does nothing for us, but okay. So the way that this works right now is when we get this like blob of data from OpenStreetMaps, and he has like a bunch of nodes that have like IDs and latitudes and longitudes, and these IDs are like unique for the whole world, right? And we don't need the whole world. We only need however many nodes are in Vancouver. In reality, we only need the nodes that are attached to roads in Vancouver, right? And so what we do is we look at these nodes and we kind of just say like, okay, this node has index 0, this node has index 1, this node has index 2, and then we write them to like this like binary blob as just like two little Indian floating point numbers. Then when we get into like the roads, we say like, okay, so this node is referencing ID 11107954322, but we know that that's index like 5, and we kind of map it that way. Now, the problem is the data is kind of structured so that nodes come first, ways come second. But if we want to limit our data so that we only write down nodes that are attached to ways, we actually have to like parse all the nodes, then parse all the ways, then write the nodes. We kind of have to like change the order of stuff and like kind of buffer some stuff in memory. We could get a little crazy and buffer them on disk, but we don't have to do that because there's not enough stuff for us to really care that much. It's like what, 25 megs? Like we're chilling. We're big chilling. So I think what we're gonna do here is we're gonna have like some sort of like node list, node cache, and what is he gonna do? Let's think about this. So we have this like list of way tags. Like this is like strings associated with each way. Way cache is like for this particular way. What data is associated with it. So like we find like some tags and some nodes. And in here we say, hey, we found a highway. Like one of the tags that we have is a highway, which means that we're a road. So we should include this thing. And so here we kind of want to like look at these nodes and for each node in this list, add this to the output list. So probably we want like node storage is like all nodes we've ever seen. So this is probably going to be something like what, like some sort of like hash map of node ID to like node data. And we're gonna have like node data is a structure with like a latitude, a longitude, and what else? A latitude and a longitude? I guess that's kind of it. I guess we also want to keep track of if we've already included it. Maybe we don't have to do that. Instead, we'll say we'll also have like included output nodes, node IDs, is going to be a auto hash map of I64 to void. So this is just going to be like, we only care about the keys here, and we'll say that like, these are the keys that we want, these are the data associated with them, and then at the end of our like parsing of XML, we can like rip this list and use that to index into this list, and then use that to write into the writer. Yeah, okay. Sure. Sure. And probably we also have to cache the way output. Let me think about this. We could also just kind of flip the order. Right now, nodes come before ways. But we could just flip it so that ways come before nodes, so that we don't have to worry about it. But I'd rather not. I'd rather keep the parsing the same, which means that we also kind of have to cache our way output. So we have way tags, we have way cache, and so here we're just going to say like way node, way nodes. It's going to be like an array list of a bunch of I64s. So we're gonna keep using like the raw index, then or like the how do I say this? The OpenStreetMaps ID. We're gonna keep our things as like OpenStreetMap IDs. Then when we try to write them out, we will convert those into indexes as we write them out to the writer, which won't happen until after we've parsed all of the XML. So I think that makes sense. Hand wavy seems like it makes sense, which means that this way cache needs to keep its nodes as I64s instead of U32s before it was using like their indexes. And then here, instead of ever looking at the ID lookup, he's just gonna stash them as like this. Seems reasonable. Seems reasonable. Which means that this like push node function somewhere must be called. Surely. Is it never called? Am I fucking stupid? Wait, cache, push. I'm confused. I'm confused about how this ever worked if that was not happening. Oh, it's because when we were like refactoring before stream, we made some mistakes and then we went back in time and we just forgot we missed a change here. This was supposed to say user data dot way cache push node. And this should now just say node ID. There we go. There we go. Do you code anything else pre-stream? I mean, it depends on what you mean by pre-stream. Like in our happy hour today, we did some work. There's definitely like the state of code at the end of these like 2-hour segments is like totally fucked, right? So there is work to do in order to make it not suck, but we don't like the motivation to code things outside of what we're working on stream gets kind of low because the amount of work that is needed to keep this stuff moving so that every day we can make good progress is it's a lot. So doing more is like, I want to play video games, man. Okay, so this guy's now sending out a node ID. This is going to the list, and then we said that we have to cache these somewhere here. So now when we reset the node cache here, instead of pushing the nodes into the writer right now, we have to say wait nodes append slice, and we are going to append this slice. No, this is just a raw append, huh? Because it's a double nested array. And then we have to be careful because this thing is going to get freed on reset. So we actually want this to be like a to-owned slice. And instead of handling errors reasonably, we'll just throw a little catch unreachables all over the place. Okay. What do you play? I've been playing a bunch of Apex and a little bit of Trackmania for the most part. Okay. So when we run once we get through like the whole parser, this is now when we're going to write stuff out. So we're going to look at user data dot, I guess here probably is where it makes sense to write down which nodes we want to keep. So output node IDs is just going to come from this. So we're going to here say, for each node, we have an ID, and we will kind of put this in here. Right, and this is output node IDs is devoid, and then the node storage, I don't remember writing this anywhere. So when we see a node here, we call handle node, and this has to go to node storage instead of the data writer. Put node ID, and then here we have lat, lat, and lon is equal to lon. Crazy stuff, I know. But it must. Next person will be writing anti-cheat for Apex. Dude, I wish it would be so fun to write a cheat, but it's just like so fucking immoral. But oh man, I just wish I could do it. Like it would be so fun. It would be so fun. But we can't. Not allowed. But if you were gonna write a cheat, Apex is the game to do it because they'll never catch you. What is this thing? Waycache has nodes or I64. I guess it would be fine if we wrote our own game and then wrote a cheat for it. That would be legal. You could probably also you could probably do something where you like almost incentivize it. We could make a game where the whole point is for people to try to write cheats. That'd be kind of fun. That'd be kind of fun. This is a auto hash map from I64 to node data. Initialize with the allocator. Expected 2 arguments. Who does? Init? No. The fuck is he? Oh, comma. Less add. So like admin code, put less substream and loops. Yeah, I guess so. Okay, this dnit probably has a dnit the no storage, and also the output node IDs. And how fucked are we? Missing field output node IDs, which was a auto hash map of I64 to void. Okay, missing struct way nodes. Okay. I don't remember adding this, but that's okay. What the fuck is way nodes? An array list. I have absolutely no idea how much of this I've implemented, which is very funny. I'm just like following errors and like, sure. But I'm pretty sure that we didn't finish here. I'm pretty sure here we were supposed to actually write the stuff out. I guess we should make sure as well, this like data writer does not have to be in the like user data that we're passing to the XML parser anymore, because we're not actually trying to write anything out anymore. We are only trying to store stuff for writing later. So here we can say var data writer is a data writer. And how do we manage this? We are looping through output node IDs. Yeah. And we are saying data writer push node given the node. So this comes from the node storage. So we say const node is user data node storage get node ID. Then we have node dot here we say or else unreachable. We'll have to go back through this and fix our shitty error handling eventually, but shut the fuck up, you know? So this goes lon lat. And this has to be, I guess we don't need to say unreachable here because this actually, we could return errors here. So we'll say error, no node. That's much better. Now I'm not angry at myself, which is great. Okay, so now we rip through the ways. Way nodes. And this is going to be way nodes. And here we write out a push way nodes. And we write the way nodes. And that's actually like very nice and clean. And he already does everything we need. So it actually could work. There's like a, you know, a 30% chance, I feel like, that once we compile, it will work. Which is pretty high. Pretty high. 311 missing struct data writer. So right now we want to take this data writer out. We did say, fuck this data writer. Nobody should be using him. But clearly someone is, and it's only dnit, which is fine. User data output node IDs is not indexable, so that makes sense. So here we have to get some sort of iterator. Is there like just an items field? Probably not. It's more complex because it's a hash map. And we want like a key iterator probably because it's only keys. And output node iter, I guess we'll call it. And we'll say while node iter next. expected just blah 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 is var. Yeah. And then here we need to dereference this because it's a pointer. Little pointer boy. Expected error union type. What? Does this not? This does return error. What's he complaining about? What's he complaining about? Node. Oh. Oops. Found void. Expected error union type. Am I fucking stupid? Node data. Who is expecting error union type found void? Oh. Why is this not failable? Oh, because you just wrote catch unreachable inside like fucking dumbasses? Sure. Sure, I'll take it. I'll allow it. So here... Ooh. So here we're taking I64s as well as the lookup. Actually, we don't even need the lookup. The lookup's already here. So here we say, instead of writing the node index, we write self node ID index map get self node ID index map get node ID. This is not IDX, this is node ID now. Or else unreachable. And this is node IDX now. Much better. And this is found a U size. Can I just map them to U32s instead? Why is this storing U sizes? I guess it's kind of reasonable because we store like indexes into an array. Whatever, it doesn't fucking matter. We'll cast it. Please it. Expected error union type found void at 343 because this doesn't fail because we just like fucking crashed the program instead like dumbasses. No field named data writer at 348. Still not sure if you do unreachable or catch panic. The difference is that I'm pretty sure that panic will trigger in release fast mode and unreachable will just kind of like get optimized out. So in reality, writing unreachable there is kind of fucking stupid. But you know, oh well. Oh well. I'm not really too worried about it because in reality, we shouldn't be doing that at all. We're kind of taking shortcuts and cheating. Okay. It might work. It'd be cool if it did. So let's run make site. We'll run it to the normal output. Make site. You using unreachable for error handling is illegal behavior. Yeah, don't do it. don't do what I do. Do what I don't say. Don't do what I do. Haha, he said do. Shut the fuck up. It's just why? Like why? This is how am I going to get serious people who want to learn to code if I keep saying haha, he said do in the middle of stream? It's like who's the target audience? Daddy's losing it. Like it's just like surely the Venn diagram of people who laugh at poo jokes and the people who want to learn to code, surely that's not that big, right? Like it's like just me. Okay, so this is much smaller now, which is an indication that it did something right. We're leakies all over the place, but that's fine. I don't give a shit. And here, if we refresh, do we? Oh, that's data. That looks like a real map. That 30%, I'm now up to 75%. Even though I'm seeing it, I still don't believe it. Seeing is believing, but not in this case. In this case, believing is believing. It does look like it's working though. It does look like it's working. Chat is literally voices in the settings talking to himself. Dude, I'd believe it. Okay, so now we should be able to run this thing. And we saw 288 milliseconds. I want to know, is it any better? Fuck! It never works because we're... Wait, why is that crashing? Index out of bounds. Is this erroring out on us? No. Who is indexing out of bounds then? Who? Who? Less data and different node IDs? It's possible, yeah. We could be fucking that up somehow. The tag pushing might be, we might have fucked up, like we might not have like coordinated between the tags correctly. Oh, different node IDs because we hard coded them before, like fucking dumbasses. Right. So we need to get new ones. We need to find the new ones. Yeah, you got there before me, for sure. But let's just kind of like, okay, error no path. Let's use these ones. Local zig, and let's just kind of, what? I guess we should copy paste these. So what are the chances that we like type them in right? Like near 0, right? Okay. That will do it. And we need to de-optimize. Not de-optimize, we need to call with -d optimize. It's like the opposite of de-optimizing. But we are optimizing for release safe for a fair comparison. Because I'm curious. It does not look like we gained any speed, to be honest. It's actually slower. How the fuck is that possible? Oh, I guess it's probably not a fair comparison. I guess, probably which node I start from must have a big impact. Because which nodes we visit first, I think that you can visit each node more than once. And so it's not just like, you're not just visiting every node one time. You're like visiting them through all the paths that you might hit them through. So that's not a fair comparison, but we did get slower. So we can kind of just assume that that was not the major slowdown, which is good for us because I didn't think it would be, but I was kind of curious to see if we would see like major gains, just because like you hear stuff about like cache coherency, and it's like, sure, we want to reduce our cache misses, but probably reducing the number of nodes from 20 megabytes down to 10 megabytes, you're still probably gonna have a fuck ton of them. That would be my guess. Okay, I did want to look at U32. How do I call this? I wanted to try path planning with U32s as well, but maybe before we do that, maybe because that took longer than I thought it would, let's just get into like real benchmarking. Real benchmarking. Because we need to do real work. Well, not real work. None of the thing we do here is real work, but I do think that we should make informed-ish decisions. So we should just be able to call like perf. Do I have perf installed? I do not. Let's get out of this. Let's exit our next shell and let's go into shell next and say Linux packages latest perf. Let's get that bad boy in here. We love perf. He's our friend. Speaking of avoiding cache misses, I've been reading some of the data or the design book. It's some interesting stuff. The data-oriented design book. Surely there's more than one, right? But yeah, that stuff's crazy. It's like pretty cool, like how much it can make if you like do a good job, right? Because like I think what we did here, what we really would want to do is we would want to make sure that like we would want like different areas of the map to have the same cache locality is probably how we get good efficiency gains, right? Like the as you're walking the graph, you want to make sure that like the next node that you're likely to look at is close by in memory to the node that you currently looked at. There's probably something about that that you could probably actually get some gains out of, but instead we will just ask perf what the problem is. I think it's like this. Perf record call graph equals dwarf. With debug info, I think it's something like that. I can't remember. And zig out. Yeah, so let's just kind of get that shit out of here and do perf call graph dwarf just g, and let's just kind of see what we get. No. Record. We need to record. If you're interested in analyzing cache misses, then Poop by Andrew Kelly is great. Okay, so maybe the overlap is higher than I thought. Maybe it's high. Maybe I can't even tell if you're just like making a callback to me making jokes about shit, or if somebody actually wrote a tool called Poop, and now you actually have me curious enough to Google it. GitHub Poop. Sick. Like, sure. Whoa! You weren't fucking with me. That's like a real thing. That's so funny. Somebody's literally credited. Like, yeah, I know. That's so funny. Wow, I thought you were just making a callback. That's crazy. Um, okay, let's maybe profiler Firefox com and let's look for what are the fuck we're working on. What's the project called again? FMAP. A really sane name for a really sane person. We have to call perf script on this thing. And then we should have this thing we can open in Firefox, and it should tell us how fucking slow we are and why. I want flame graph. So we have like some amount of, we have like 730 milliseconds on init on basically just loading data, sure, whatever. Then we have like 3.8 seconds on the actual path planner, and it looks like some of this is from fetching neighbors around 500 milliseconds. 500 milliseconds on distance calculations, where most of that time is actually spent in fetching the node IDs. So both of these node adjacency map, get neighbors, and point lookup, these are just like stalls on like fetching things from memory would be my guess. I did A-star for a job application once, but I didn't even do the most basic optimization. That's why I still progress in either. I mean, in all honesty, there's no reason to be doing this, right? So a lot of time spent in less than as well. So this is like the vast majority is like. Then there's like another small amount over here as well. I wonder what this is. This is like. I actually don't know what that would be. We can probably find out though. Perf annotate. Where is this taking me? Get neighbors. Right. So I guess it took like perf report. I want to look at. This was in path planner run. I was kind of surprised to see such a high number there. So that's kind of this. Why does it here? It's saying that there's like a large amount of time here. Here he's saying there's like no self time. Why is that? This matches up though. 35%, 33% and less than, 10% in distance. Okay, so can I like type? I think it's A here. No, no samples. Probably appeared just in a call chain. Oh, it's getting inlined into main. Oh, yeah, I see. So we're seeing. Oh, this is confusing. Can we? I guess like it's kind of like not reasonable to ask it not to inline stuff because the inlining is probably like a major performance improvement. Fuck. What I want to see. Yeah, that's annoying. It's annoying. How do I like jump around to like high H for help on key bindings? Here we go. I want to see like other expensive symbols. Go to hottest instruction. Cycle through hottest instruction. Tab and shift tab. Okay, here we go. So this is neighbor iteration. This is order. Okay. So this is I see. So this chunk here looks like it's like the updating of existing node IDs. I think it's this. Hold on. Run. I think it's this. No, sorry, not this. This. Neighbor queue index. We can double check that. Tab. Yeah, here. This is yeah. Okay. So, and this is like with 13, 10, 6, so maybe like 25%ish, and that looks like kind of 25% here. Okay. Got it. So a lot of this actually is just memory, huh? Like this stuff here, get neighbors, this is all we have like an adjacency map where you jump into an array to a specific position where you say this node has like this list of neighbors. So that's all this is doing, if I remember correctly. We can just take a look. Yeah, that's all basically all he's doing is he's just jumping into storage and pulling out a contiguous chunk of bytes. Point lookup get is also just jumping into point storage. Self points, self storage. This is something else. Right, because this is based off neighbors. That's based off like input data. Then less than. This is also just jumping into like half jumping to data, half calling order. Okay. Sure. And then maybe like 25% queue stuff. Interesting. Interesting. Can we look at like cache misses perf? Like I think that's something you can do. Why doesn't it report cache misses? I'm pretty sure it does. Perf stat. Oh, I want to call, no, I don't want to stat. I want to look at perf report dash v. Help. How do I get like switch events? No. Perf view cache misses from report. I guess we could also just read the man page, huh? Man perf report help. Cache. I just want to see like if it's like the vast majority is like memory lookup. That's all I want to know. That's all I want to know. Perf get cache misses report. There you go. Dun, 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 dun. Oh, do I have to like specifically ask for it? It's possible. Dun 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 dun. Dun. Let's see. Let's see. Like let's just copy paste what this guy said. Just to see if it like tells us something that we want to know. Zig out bins map output map data bin and output map data JSON. Like, does this just tell me what I want to know? This does tell me something, but it does not. I don't want annotate. I just want to like details. No. I just feel like he's saying that this tells me something, but I don't feel like it's telling me anything. You know? I feel like this makes no sense to me. People are just saying, they are just saying use perf stat, but perf stat's kind of like live. I want to see like I like the description, making square wheels so you can appreciate the round ones. We do make very square wheels. Like they are very, very square. Perf report event count. There we go. Event. Dun 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 dun. Dude, it's so hard. Just give me a fucking list, man. Like, help. Expand clouds, call chains, call chains. I want to like just see like global info. Available scripts, print histograms, header information, context menu, percent limit, kernel map, column headers. Up and down, navigate. I already forgot everything. So this is telling me samples of event load misses. Oh, here we go. Wait. Nice. So this is telling me, I guess this isn't telling me like ratio of hits to misses though. This is just telling me what is missing. But it does kind of line up with our guess from before that it is kind of like all the same places that we were seeing high utilization are kind of all the same spots that we're seeing high cache misses, which makes sense. So I guess the question becomes, can we reduce it? What else? Like, what are our other options here? Our other options are improving the priority queue usage a little bit, as well as maybe this math order is like a little expensive from floating point lookups. If we were to switch to U32s, maybe that goes faster. I don't actually know kind of like the performance difference there. Okay. What? So get neighbors. He has this thing. Self-storage start end. This stores node IDs, where the node IDs I think are U32s. And I wonder if we could get these down to U16s. This tool is more like hyperfine, gives you a report with cache missions and stuff. Yeah, it might be worth looking at that actually, because it does feel like it is a lot caching. Does feel like that. Before that though, I do want to just see if we can get the node IDs down to U16s. That's a lot better. What are the chances that poop would be mentioned twice? I mean, it's possible that he saw it before and he's just like giving me a little reminder. 65536. How many nodes do we have? We can maybe on init write down how many we have. Debug. I guess we need to do log debug. Num points is this. Otherwise, if we try to do std debug print, the WebAssembly compilation won't work. What the fuck is he bitching about? What is he complaining about? Expected tuple? Oh, fine. I'll read the little dot thing. Why not? Oopsies. From map, and we won't record shit. Let's just take a look skis. Little look skis. Uh, 624,000. So we can't fit that. Right? Yeah, not even close. So U32's semi-reasonable there. There's not like an easy gain to just say, fuck it, do less. I am down to just kind of look at poop. I'm down. What does this thing do? We measure. Ah, nice. Okay, sure. This will give us some information. Fuck it, yeah. Get clone poop. And zig build it. Probably we want to optimize release safe. Almost certainly, except safe like this. Why not? I'm trying to think. Like, is there any just like absolute brain dead memory layout stuff we're doing? It's like very possible. But we'll see. We will see. What project is this? Maps. So we're running Zega. Are we built in release mode? I actually can't remember. I can't remember. Give him a sec, he's thinking. Okay, and then poop. Sync out bin poop. What does this do? Okay, sure. And compares the performance of the provided commands. Oh, so we have to do a comparison. Can we not just run one thing? Oh, I guess command 1 to command n. Like we might be fine with just one command. So this is zig out bin map with output map data bin and output map data JSON. Hello, bug. Hello. Interesting. Interesting. This is kind of fun. So, wall time 4 seconds, memory usage, CPU cycles, instructions, cache references, cache misses, branch misses. This information, I guess this just helps as a comparison thing, right? Because these numbers raw don't really tell me a whole lot, right? They just tell me that there are numbers. I would probably want to compare the output of this after making some changes to see if those changes heavily reduce the cache misses or branch misses and stuff like that. Okay, let's just start poking around. So we know get neighbors. We know get neighbors is a problem. And we can maybe look at get neighbors. So we already thought about this a little bit. And we already tried to say, hey, all of our node IDs are going to be in one big chunk of memory. And then we are going to store the starts of these things as we go. You could reduce this by turning this into a U32. Not that I think that would have a major difference, but we could try it and just kind of see what happens. I'm curious. Right, we could try it. Oh, but we don't really know that it will be U30. I guess we'll find out. It'll crash if it's not. So I guess what we also want to do is we want to say, we want to copy this to baseline. Baseline. Sick. And then we sig build optimize equals release save. I don't think that this will make like a major difference at all, but at least now we can kind of play with the idea of comparing. And so now we call poop again, but this time we compare it to svmap baseline. You can do it with perf stat -e. Ah, that's what I was probably looking for, is perf stat. That does sound familiar. Oh, no, wait, but perf stat is for live running, right? And I want to like look at like a recorded thing, I think. But maybe not. I can't remember. Who fucking knows? I don't know what I'm doing. That is true. So this is the new thing. This is the old thing. And here we got the old thing is supposedly faster, which doesn't make much sense. Should put baseline first. Does it matter? I mean, it's just like the order changes, but like I don't think it should make a difference. I don't think. But yeah, I mean, like here, I'm surprised. I would think that for sure reducing. I mean, it just. I mean, I think that just means that we're like hitting variance, right? I changed that one thing from a use size to U32. That should reduce memory usage a little bit, but in reality, it just doesn't fucking matter, which makes sense. That does make sense. Because really, I guess this is probably what we're looking for, right? Is like cache missing. Night, everybody. See you next time. Later. I'm surprised that it's like noticeably faster. I guess it could be that the all of the int casting is actually like noticeable because of like of safety checking. That seems like actually possible. Because like this is just having the opposite of the intended effect to me, which is just confusing. It shouldn't. It should not. It should not be worse. It should be the same. But this was consistently 10% different, so clearly I don't get something. Clearly. Clearly. This is a fun little game, though. Ah, there we go. That's interesting. I wonder, with just compiling with release fast versus release safe, I wonder how much of a difference that makes. So can we just like undo that change to U32? We should probably be using Git a little bit more intelligently here. I don't know, some stuff changed. Use it intelligently, he says. Okay, let's go back here and we'll turn back. We'll put this stuff all back to U size because this is kind of like the base state. So this is also U size, and we can zig build optimize release fast, and then we should this should be essentially the same as the baseline. Just well, we should compare. We should make sure it's the same as the baseline by compiling as release safe, and then we can at least add -u and say baseline. We can write down baseline so we know we'll have a good state, and then we can make changes based off that. Can we make this only run once? I don't really feel like. I mean, it's fine. It's fine. He's thinking. He's thinking. This is a fun little game, though. I'm having fun. I don't know if I'm making any progress, but I like watching the numbers. Okay, yeah. So our baseline has 0 delta at release safe. And if we do release fast, then we can run this experiment again. And I want to change the duration. I think that I saw there was like a -d field so that we can say, go slower, like do less, please. You need to run it multiple times because Linux maps files to memory pages that are cached. But that's fine, I think. I think it's fine. I'm not really too worried, but like, because I think that like the memory that like the things that are causing a lot of pain right now, I think are just something else, but maybe not. I don't know. We'll see. We'll see. We'll see. So yeah, just raw release fast gives us approximately the same gains. I mean, we do actually see a little bit of decrease in cache misses by reducing the memory there. So that does make sense, right? So the name of the game is just use less memory because we do see an improvement. It's not a huge improvement, but this is like what 170 million to 182 million cache misses. Maybe that's relevant. I don't know, man. Who fucking knows? It's hard to like wall time doesn't feel like it's a good measurement, especially while streaming. So I think that we should try to use like these other pieces of information, right? Like CPU cycles instructions 17.5, 19.5 from 20 and 20, 21 and 28. So like, oh, sorry, 18.5, 19.5, 17.5, 19.5. So our CPU cycles went down. Instructions did not. Our cache misses. Wait. This is the Wait, this is sorry. This is the one with no changes. This is U sizes. This is U32s. Yes. So here we went from we should have more CPU cycles. Fuck. I don't know, man. I don't know, man. But the cache misses did go down, which is maybe good. I don't fucking know. Branch misses. In this one, we had 50.8 million. Here, 48.2 million. Branch misses is probably relevant in some way, shape, or form. But what do I know? What do I know? Also, the idea that U size to U32 would make a difference is not really true in WASM. It's not true in WASM because U sizes are U32s in WASM. But fuck it, you know. So, is there a way to make this go fast, fast, zoom, zoom? I guess like the only thing that we could do. Sorry, I'm just thinking. You could like try to pack the data into like less bits, which maybe is doable. Or you could try to make it so that stuff like lines up with each other. So like things that are close to each other are are like aligned in memory. Here, we're kind of randomly going through node IDs, effectively. For node neighbors in neighbors, we're just kind of saying that like, I guess the top level thing that we're looking at is the node ID, followed by random order of his neighbors. Yeah, I don't really see anything obvious here. So maybe the name of the game is move on a little bit. What else could we look at? We could look at like kind of like the frequency with which we have to access different areas of memory here. So we could maybe look at seeing if stashing scores for comparison close by makes sense here, right? So here we kind of have our F scores for all nodes, which is a lot of nodes. But in reality, our priority queue is probably only going to have like a very small slice of those in the queue at any given time. So probably we could probably get the number down if we, instead of storing node IDs here, stored like node IDs and their scores? Maybe? Possible. I mean, I don't fucking know. We could look. So that would be like no const node with score is like an ID node ID and score F32. F score maybe will just be clear. And then we say like node with score here. What kind of allocator is run using? It's short-lived and called often, right? Maybe trying it. Oh, that's a good point. Is it? Let's look at that. Reconstruct path. Oh yeah, this is this is only called once. This is fine. It's called in the priority queue as the queue is like changing size. So arguably this could be problematic. However, I would assume that the number of allocations here is not actually that large, unless remove or null like shrinks capacity. But I don't think this will ever shrink itself. That would be silly. Shrink and free. Yeah, I think I assume that I need to explicitly ask it to shrink itself. So it's probably not that bad. I wonder if we could maybe get away with like increasing the capacity up front. Like if we just like set this like 1,000. Like at least then it won't like realloc all the time. Although maybe setting it to 1,000 is problematic because maybe that makes us go slower. But maybe. Maybe. You never know. You never know. I suspect that that's not going to be a major problem though. Does anyone know why in C code in Zig code we don't have any overhead? I mean, it's just like everything compiles down to assembly. Your calling convention is known. There is some amount of overhead. Saying no overhead is probably not quite true, right? Because like you have to use the C calling convention, which doesn't really exist, but like you have to use like the calling convention that everyone agrees on. So there is some amount of overhead there where like how do I say this? Zig internally can make decisions to basically push things into registers because there's no like forced ABI. But once you go into like go cross language to C, you have to follow the language rules of like push this register, then put that on the stack. But in reality, it's pretty much no op. But like at the bottom level, all it is when you call a function, all you're doing is you're saying like put function argument 1 in register 1, put function argument 2 in register 2, and then jump to this pointer, which is like a function in memory, right? And that does something. This is a smaller number. I don't remember what change we made, but this number is a number I haven't seen yet, which is maybe good. We could maybe see how fucking slow is this if we don't run through poop. I'm curious now. Map. Did we see like is this like a visible improvement? You know? Who fucking knows? I don't. Output map data bin and output map data JSON. Syntax error. That's true because I'm not parsing the same thing. Baseline was safe, right? Yeah, probably. This is also still. We also wrote down 288, but then we somewhere earlier were like, oh, but the number got bigger because 388. That's what we saw. So it's like, I don't know. Maybe that's shorter. Who fucking knows? We are being very imprecise. We love imprecision around here. Oh, right. What we changed was the queue capacity. So I guess what we should do is we should actually like we should be a little bit more scientific here, and we can zig build optimize release fast with no queue pre-capacity. Just use vibes. Yeah, exactly. We just use vibes. So we will copy this to smap queue no cap. No cap. Then we will set the capacity and we will run that. And then we can poop that thing. So instead of baseline, we'll look at smap no q no cap. No cap. He's not playing around. No cap mentioned, poop mentioned. Perfect. We are true Twitch streamers at this point. So fucking stupid. So no real noticeable change in wall time necessarily, but big green number. We like green number. 10% branch miss improvement. Let's go, baby. Which probably makes sense, right? Because there's like somewhere he's like pushing to the queue, doing stuff. Okay, I suspect that there's right what I wanted to do. I forgot that I wanted to do something, and it was that I wanted to try stashing the scores of these things like along with the IDs in the queue, so that when we call less than, we don't have to jump into the F scores array. I did want to see if that does something. I also think, I bet the F scores array is not necessary. Yeah, fuck it. Yeah, it's definitely not needed. Because F scores, um, he is just the G score plus distance. So this is like this is just duplicated information. Just fuck F scores. Just fuck F scores. Who needs them, right? Who needs F scores? Nobody. And then here we'll just say that we will stash the F score alongside. Maybe you could even recalculate. If you recalculate, you would need to like look up the G score, so it doesn't really matter. So, is there something to memoize? Dude, memoize I think is like the funniest fucking word in all of programming. Because it's like the idea that we're just like it just means memorize, right? Like, am I fucking stupid? It feels like it just means memorize. Um, But I also would think that if we're spending a lot of time in like cache lookups, I would think that memoizing things would be bad. That's kind of my intuition right now, but also what the fuck do I know? You know? So we want to calculate the distance from neighbor to end, I think. Was there before? We'll undo a lot of times. It was neighbor to end, and then we'll redo a bunch of times and hope we don't fuck anything up. And then we're gonna store the F score along with node ID. I think Andrew said recalculating math is super fast versus memoizing. I did see that in his like data-oriented design talk that one time, which I think it makes sense to me. Does make sense. Does make sense. And if we start seeing a lot of time spent in math, then we can maybe start trying to improve like, feels like there's like more. I like have better intuition on what to do there. So, so we'll call this node with F score. This is going to ID node ID and score F score through 2. This is going to store node with F score. And then here, somebody asked why does less than return an order, not a boolean? It's because I called it less than, and it's just not a less than function. I just lied. And you have to put up with the consequences. You know? And that's just, sometimes the way it is. Okay, so then here we're gonna say we're just gonna look at A F score and B F score instead. And there's actually no self here anymore, so this is just gonna be a context is, we're gonna call this void. We don't need a context passed anymore, which is probably good as well, probably. Which means that like down here, the context is just void. Which I think all makes sense. I think this all makes sense. I guess you could also reuse priority queue and just reset with capacity before use. Yeah. But I mean, like, the vast majority of time is spent, like, in this loop. So I think that, like, wasting time on trying to, like, fix this stuff is, like, kind of minor. That would be my guess. Right? Like, but I mean, we should confirm. But, like, when we look at that, like, that flame graph here, it's like, this is 4 seconds spent in here. How many of those 4 seconds are spent like initializing this queue? It's got to be like near nothing, right? It's like all like less than, distance, like get neighbors, remove, right? Like I'm and we saw a lot in like this as well. But we'll see. I also am just making stuff up. Let's always remember that I just make stuff up, and you guys shouldn't believe anything I say. So here, oh, this is kind of confusing, huh? So the equals is actually based off of the ID. So if A ID is equal to B ID, this returns EQ. But otherwise, otherwise we compare by F score? I guess not necessarily, because here they're kind of saying like, here they're assuming that if they're equal, then it's the same node. So I think that we do have to do this, and then here we actually should not let them have the same F score because we're expecting them to be different when we're walking the thing. So we can just say like, we'll just like cheat on tiebreak. In reality, we should not be walking this. This is a stupid way to do this. This is like fucking brain dead. We should fix that as well. I bet you that will have some improvements. But we will see. Okay, so now when we add we don't add neighbor. We add ID is equal to neighbor, and score is equal to F score. Fuck. Nothing ever works. It's always fucking broken. Right, because here this should say void. Which does make sense. Q add, there is a Q add here, which we need to initialize with ID is equal to start and F score is equal to self distance start end. Okay, we're getting closer. No value in node with F score, which makes sense. So 98. This is ID value is equal to end value, and then he's telling me I don't have to compile again. We'll see this. No, this. So this is also ID. Boom, boom. ID and ID. And this should just be less than with void expected type path planner something something. So this is item, this is neighbor. So here this has to actually say const neighbor with F score is equal to this, which is node with F score. I guess it makes more sense to kind of put this on this side of the brace, or the side of the equals, and we say F score is equal to F score, and ID is equal to neighbor. And then here, we're allowed to say neighbor with F score here, as well as down here. Close. 71. These both have to say dot value. Yep. Yep. Optimize release fast. I think you can also place that while with IDX to 4, but I don't think it'll change anything. This one? Yeah, that's true. This is just like brain dead though. Like whatever, we need to fix this for sure. Poop. So here we have to stack. We already had the improvements of this minus 7.8% on branch misses. So remember that. We need to remember that because we're bad at keeping track of what we're doing. But it's fine. It's fine. We can make poorly informed decisions because the only people who use our code is us. Holy shit, let's go, baby. Wait, that's like a very like visible improvement. That's sick. Look at us go. So cache misses went down by a lot. Cache references went down by a lot. Wall time went down by a lot. Can we like just run this thing like fuck poop? Okay, guys, don't no. Okay, so that's 279 down from like what was it? It was like 358. So that's like a pretty fucking big improvement. 279 over 358. That's like 75% almost. That's crazy. But does it work? Look, man, that's not important around here. We don't care if our code works or runs or even really if it compiles. Just number go down. But yeah, we should test. I mean, that looks like it works to me. That looks like it's planning a path. Whether or not the path is correct, who fucking knows? And can we... Okay, the degenerate case is still pretty fucking slow here. In fact, I don't even know if this is the degenerate case. No, this is just it part using like a whole fuckload of the city. Yeah, it's still pretty bad in like the really bad case. But I mean, we're definitely seeing it improved a little bit. What did we do to improve? It was so before we were stashing... Okay, let's see. We copied... Oh fuck, I just closed my fucking browser window like a dumbass. A star Wikipedia. We were basically copying this guy, right? And he said, store your F scores here and your G scores here, where your G scores are kind of like, as far as we know, like if you add up all of the paths that we took to get to this node, this is how far it is. And the F score is like, if we just like straight line distance from that point to the end of the world, plus the amount of time, like the amount of distance that we had to take to get here, what number is that? And we just don't store F scores anymore. Instead, I just shoved F scores into the map. Because my thought here is that distance, the F score, is just like G score plus straight line distance. So in reality, there's no like real information that we're gaining by storing that, right? It's just like all we're doing is we're calculating straight line distance, and we can calculate that again later for pretty cheap, right? So what I do is I just like calculate straight line distance, shove that into the queue so that we're only caching straight line distances like F scores for things that are close by. And then also that means that like as we're doing this like queue shuffling and management and stuff, we don't ever have to jump into some other array where like all the data is like kind of right next to us already. That was kind of like the thought there. And it did look like it made some improvements, which is pretty cool. Pretty cool. And if we then do our little perf record call, let's go back to call graph dwarf this stuff. Let's see like what type of like where all the time goes now, because like the way that like time save spreads could be kind of like unintuitive, because it's kind of like if everything else is cache hitting now, then it might go a lot faster even in like a completely different area. Oh my god, fucking Firefox. Do you guys get this shit where like it just thinks that you're hovering a file when you're not, and like it's like unfucking fixable? I don't know how to get out of this state. It's like it fizzes me off. Fuck. Oh, I think we also have to run perf script. I see this like all the fucking time. It's so annoying. If I like close this window and open it again, just like fucking face it. I think it's something to do with like Firefox on Wayland. Like maybe in combination with KDE. So it does look like we're still... Ooh, guys, look, we see math taking time now. I mean, not anything significant, but like the things have like slowed down enough that math is showing up here occasionally, which is very cool. I guess also we increased the amount of math we're doing, did we? I don't think we did, but maybe we did. I can't remember. So we're still seeing a lot in get neighbors and point lookup, as well as this less than function. This less than function is still going crazy. Which is maybe reasonable if this queue shuffling is taking long. I think I suspect that this queue shuffling is just taking a fuck ton. Oh, you're on Wayland. I was about to show on X11. What's point lookup? Is it a hash map? It's just an array. Point lookup is... Here, we can show you. Point lookup is... this, essentially. So it's just like a wrapper for array indexing times 2 and times 2 plus 1, because I didn't want to do this. So this is just like data comes over the wire in like a bucket of float 32s. And we just like stick that into WebAssembly memory, and then we're like, never touch it again, baby. We'll just look at it straight from where we got it. Okay. So I want to know, I think that we can like perf annotate. No, perf report. And I think I want to know There's one that goes like backwards. Perf show callers of function, because I think there's like kind of two areas where less than comes into play. It's like one is like when we're doing like the reshuffling, and one is like on actual insertion first time. Was it like G? Did I see somebody inverted? Perf report. Oh, we can just read it. Alias for inverted caller base graph. Yeah. I want to see like who calls something. This is not inverted, I feel like. Yeah, I want to know. Oh, maybe it's here. Smap DSO, run scripts, zoom in. I swear I've seen it somewhere where you can like, you can see who called something. Okay, let's get crazy. Let's just fucking run it in debug mode. Right, because in reality, we are also running in debug mode sometimes, and maybe that's kind of nice for us to be able to see how fucked that is, you know? Holy fuck. Holy fuck, it's so much slower. Oh my lord. That's crazy. Right, because like it would be nice to some extent if we could use debug mode at least a little bit, but I guess we could always argue that we could use debug mode for smaller sections of the graph, and that would also be fine. Holy hell. He's going crazy. Like, I remember seeing, like, I could go here and, like... Ah, yeah. So here, less than is being... I mean, it's all inline, even in debug mode. Unless, did I run it? I did. So, yeah, I guess it is. It's just all inline anyways. Um... Oh, wait, but maybe this is interesting? So some of it is in remove or null. Some of it... This is 3 different calling locations. Okay, yeah. So... How do we annotate here? So here we can see that this is the less than call usage in the like searching for thing. Can we look for more less thans? Is that the only one? Is it because like if I have to annotate this one to see it here? No. Annotate? No symbols for the local main symbol? That's annoying. Oh, fuck. Oh, I didn't want to get out of here. Oh, no. So here. Can we like search for less than here? So you see it once here. Can we jump to next? Oh, that's not fun. Okay, how do I go back? Less than. Where are my annotations? Have we tried call grind? That's kind of fun too. Although I think that like the performance metrics out of call grind are just like totally fucked. That was kind of like my understanding. Because like it's like running in a virtual machine, and so like your real world usage is just like completely different. Boom. Okay, here we go. No samples. Just appeared in a call chain. Less than. So it may be in release mode, it's not a significant portion. Which is kind of fun. It's kind of, well, it is a significant portion because it says it is here, but it just gets inline so we can't really see it, which is annoying. Anyways, no matter what, I expect that this is fucked. So I did just want to try. Um, I did want to try. Somebody messaged me on Discord, and they're like, "Bro, don't update the indexes." And I'm like, that kind of makes sense, right? You can kind of like you can reuse if you like hit the same thing again. It's not the end of the world. And then also on Wikipedia, like because you kind of already know the first time that you see the first time you inspect something is like the correct time, and any future time you inspect is not like it's not something that you should be looking at anymore. But also on Wikipedia, it does talk about if you do want to update, like fucking throw a hash map at that thing so that you can like easily find where it is in the queue. So I think that basically every time we call add, can we like does it return its position? No, it does not. So if we wanted to hash table like figure out like write down basically where things live in here, it's not trivial, which kind of sucks. Kind of sucks. So maybe the idea of just like allowing duplicates to end up in our queue is fine as long as we know if the thing has been hit before. Or maybe even if we just hit it again, we're not going to get a better score here. This isn't going to pass. In which case it maybe doesn't matter. So we could try just not doing this. Maybe. We could just see what happens. If we add something and it already exists, what does this do? Seems fine. We can try. We can just see what happens. You can just access items by index directly, except we don't know where they are. That's kind of the whole problem. Is that like they get kind of like swapped around in this binary tree, and they end up somewhere in the tree, and we don't know where they are. So we like walk the tree again to find them later, and that's like fucking stupid. But it's fine. It's fine. It's fine. There's a chance that this also just gets more expensive because actually let's do a fair comparison. So we'll say this is our current baseline. We'll call it baseline. No, we won't call it baseline. That's not good. We will call it no duplicates. We'll call it, and then we will comment all this out, and then we'll compile this with duplicates. And we'll see if there's an improvement. I would like to try also the idea of just like raw ripping through the like an array and seeing if that's faster. It could end up being faster to use a like an array with no intelligent storage versus like a heap if it just turns out that the overhead of maintaining the heap is too much. You know? That's like possible. Duplicates? Smap, no duplicates. And then this is smap. Okay. We'll give him a sec. He's got to think. He's got to think. Oh, interesting. Wow, that's significantly faster. What the fuck? Wow, that's crazy. That's a lot faster. Yeah, that's crazy. Wow, we're down to 156 milliseconds. That's huge. We've like halved our time. We were at like almost 400. Wow. Sick. And then I guess we need to double check that it's still correct. Fine. Like if we have to check, we have to check. If we're gonna check that it looks like at least a little bit reasonable. Yeah, I mean that feels like a path planned. Oh, that's already like you can really feel that too. It's like the slowdown now isn't like holy shit my computer's dying. It's like holy shit that's annoying. Right? It's not great, but like at least like it's not like dead. That's actually like massive. Oh, that's pretty sick. I think we can do more though. We can do more. Um yeah, I wanted to try. Let's do this. Uh allow requeue and stuff. I don't know. Remember we're playing. uh I wanted to try fuck priority queues. So array list unmanaged node with f score, and that's it. That is it. Then here, when we say like pop elem, and we're just gonna like take our, at least not smiley face. Dude, I use smiley face so much. This is gonna be node with f scores, this is items. I guess this needs to be actually an array list so that we can do swap and pop. This is gonna be a pointer, and this is gonna give us back a node with f score. Okay. Call this q. This is just gonna be like q. We're gonna say q items stood mem find index of scalar. We can't get too crazy here because index of, unfortunately, needs it to be like a raw value. So we could do. I mean, if the only reason I would want to do this is because I think that index of is like a little smarter than what I would do. Like, which is I think that might be faster, but for now, fuck it, we'll just rip it. So we'll say for q items with keeping track of where we are. Write the for loop. I mean, it was just I sincerely think that the for loop might be slower than the alternative. That's the only reason I was looking at it. That is the only reason. You can store in multi-array access fields and slices that index of can finally commit the element. Yeah, that's not crazy. That's not crazy for sure. I'm down to do that comparison in a second. I mean, I'm already kind of on this road, so fuck it. Here we're gonna say, min is going to be, what, like, stood math max float max of f32. If item dot f score is less than min equals item f score and idx equals I. And then here we say, I guess here this has to be optional. If q items len is equal 0, return null. And then here we say we swap and pop. So q swap, remove, hell yeah. There we go. Then here we can say fuck this noise. And here we say pop lmq. I guess it makes sense to still pre-jack the capacity. That seems fine. This is append now. Okay. D in it with alloc. Okay. This expected, that thing found. Oh. Sure. Sure. And then here, I did want to say that instead of adding here, fuck it, we'll just push it. I suspect that we can dodge this append now, but I'm curious now. Because like the win that we get on using an array instead of a more intelligent type is if we can keep the number of elements in the array down. So unconditionally adding to the array is like a little stupid. But let's just see like ballpark, like what happens here. We should have said this is fmap array queue. And is my get diff only the array queue stuff? It is, hell yeah. So we can just quickly compare those. It would be interesting if it was faster. I expect it will be slower, but it'd be cool if it wasn't. So this is going smap to smap with what was it called? Array queue? Would be cool. This is like very visibly a lot slower. like holy shit slower. So yeah, that's crazy. So that's kind of funny. Branch misses goes down a lot, cache misses goes up a lot, but it's possible that if we track where each thing is, okay, hear me out. So we're gonna do this. This gets the indexes. I was gonna like cache the indexes here for some reason, for updating. Like, I don't really know what I wanted to do here, to be honest. Like, stash, like, node ID to usize in the queue? Is that what I wanted to do? Oh, oops, we need to actually stash pop. Right, this is probably stupid. Let's just be clear. Let's be clear, this is probably stupid. But, maybe not. You never know. You never know. So this goes from like node ID to usize. Init with alloc. And then here on pop elem, we have to do like q idx as well, so that we do like the the little state management that we have to do. Little accounting. Q idx is this, and then here, when we swap remove, we say q idx of the element dnid alert. Good eye. The q idx put the thing at the current end. His value is going to be idx, and then we have to remove idx as well. Not idx. This is the thing at items id, and this is q items idx id as well. Yup. Expected type this found that. Oh, catch unreachable. Fine. We'll get crazy with it. And then this equals this, and then we swap move it. And then down here, instead of appending, we say q idx get the neighbor if we get it. Does this return like a pointer? Returns a value. How do I get like a get pointer? Here we go. We say val f score equals f score. We just update them in place. Else we append. And we say qidx put neighbor in with the q.items.len-1, I guess. Something like that. Oops, this is we get the index, so this is actually supposed to be q items at val. So this can we get is f score is f score. That's what I was looking for. Okay. There's a chance. There's a chance. D-init alert. Who did I forget? I forgot to D-init this guy. Let's start with release safe and just run it because I'm not really positive that I got this right. So I want to make sure that like nothing like just full on explodes. But that we can compile with release fast and compare. You know, I don't want to run with poop. I want to just run it raw. Run it raw, baby. I mean, this is just very clearly very slow. There's no point in even pooping it. It's just super fucking slow. Which I guess makes sense. It feels like maybe even slower than the only array version, to be honest. But I mean, that was kind of expected. That was kind of expected. Of course, a binary heap would be faster. I also wanted to see in that version with the binary heap. How do we get back to that? Get status, get diff. Like, is this? Yeah. Discard all this stuff. In the version that we're using the binary heap, I wanted to know if checking, like skipping, basically everything here onwards, if we've already looked at the node, because we have like duplicates in here now because of this, I wanted to know if that's faster, right? So you could do like scene nodes is a stood auto hash map, unmanaged, I guess, of like node ID to void. Here you could do like if scene nodes contains the current node ID, continue. And then here, just scene nodes put. Current node ID and void, I guess. This is to say ID, and this has to say ID. Expected 3 arguments on 2, because you need to pass the allocator as well, probably. And then here we probably want to pre this, and then we probably also want to like preset. Fuck it, whatever, it doesn't matter. Using getter put might be faster. Because it doesn't need us to like initialize a thing. And then try here, I guess. Value of type this thing ignored, so do this. Yeah, I wanted to see if that's faster. So git stash, and we build with release fast, and we save this at the thing. At the top, I mean, instead of contains. Oh, interesting. I'll take a look. Just one sec. So this is smap no or full dupe. We'll call it full duplicates, fully allowed, and then git stash pop. So you're saying that here I can still call put. I would imagine this doesn't actually do, like, there's no difference here. And then you're saying, oh, you're just saying the whole thing. Scene nodes get or put. with allocator and current node id.id. I can see that. I can see what you're saying. So current equals this, or const scene is equal to this, and then we look at a scene dot. There's a way to say like scene found existing. There we go. And then if it doesn't exist, you just init it, but the init is void. So I think that this will allocate. I don't think we actually have to do anything because the value in this is void, I think. He's got to think. He's compiling, and then we'll poop the shit. We'll poop the shit out of it, like smap, full dupe, and then this is smap, and we'll see if the poop is faster. It's so stupid. No, slower. Yeah, that makes sense. So the overhead of actually doing the hash lookups and tracking of scene nodes is actually like shittier than just doing recalculations down here, which is kind of interesting. Not interesting. Very neat. Okay. Well, we had fun. I had fun for sure. What is our current state? Perf zig perf record. And we said the full dupe is the latest and greatest. This is the fastest that we've got so far. And if we look at this thing did I close that Firefox? I must have. In Profiler, firefox.com, we can see where the time is currently being spent. And it does look like we still have a lot of memory lookup pain and a lot of priority queue pain. But we did gain what I believe was like literally over 50% speed. Full dupe. Right? Because we were at like maybe like 380 milliseconds initially, and now we are at 156. So pretty cool. I'm happy with that amount of progress. I'm sure that there are more gains to be had and more fun to be had, but I think it is time to call it for the day. So thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to around 4 o'clock Pacific time. If you're watching YouTube VODs, you were seeing the 2 to 4 segment, which we were calling, the main course. It's dinner time, baby. And before that, we do like what we call happy hour, which is just kind of like more chill, less focused, a little more just doing small tasks that need to get done, right? If we were to leave the code in its current state, it would be shit. And so happy hour is kind of about like slowly getting to something that is less shit while having fun along the way. So if you want to check that out, you can swing by on Twitch. If you're on Twitch, there's a YouTube link in the Twitch description where you can check out like previous projects. So if you want to see some of the other stuff we worked on, we're working on this map right now, but there's like operating system, there's like a little stream intro screen, 3D engine stuff, QR code decoder, terminal emulator, all that stuff's pretty fun. There's a GitHub link in the Twitch description as well, where you can see code for all this stuff, where this will eventually end up in the FMAP repo. Like, subscribe, Twitch Prime, all of that stuff. And let's say goodbye to YouTube and Twitch. Let's find someone to raid.